Okay, so I'm just going to try to pick where we get through in class today and go from there. So it says a survey conducted by an independent agency for the National Lung Society found that 2,000 women, 680 were heavy smokers, and 50 had emphysema. Of those who had emphysema, 42 were also heavy smokers. Using the data in the survey, determine whether the events being a heavy smoker and having emphysema are independent. And so, like, we could just talk about whether it's independent or not, but like we can use the test to show mathematically whether they're independent or not. So think about if we let A equal the heavy smokers and B equal the ones that have emphysema, if this is independent, then the probability of A times the probability of B should equal the probability of A intersect B, right? That's our formula. So what is the chance of having being a heavy smoker? 680 were heavy smokers out of 2,000, so that's 680 out of 2,000 times how many had emphysema? 50 out of 2,000, and I'm going to put like a question mark. Is that the intersection? How many had both? Of those who had emphysema, 42 were also heavy smokers. So the intersection would be 42 out of 2,000. And this is kind of like a proof almost, even though we're not really writing stuff down here. If you do this side, you get 0.0085, and that does not equal 0.021. So this means that they are not independent of each other, which I think we could deduce just by thinking about that you could be a heavy smoker and have emphysema. That's what makes it not independent, okay? And then the last thing in this section talks about the independence of more than two events. So just like of two events, the intersection of those two events equals the probability of those events. So it just says if you have more than two events, like if you have event 1, event 2, on to event n, the intersection of all of those events will be equal to the probability of multiplying them together. And so it just applies, the same process applies to more events. So example 11 is just kind of showing that. So it says, it is known that the three events A, B, and C are independent, and that the probability of A is 0.2, the probability of B is 0.4, and the probability of C is 0.5. Compute the following. So this is just showing that formula. The probability, since they're independent, of A intersect B has to equal the probability of A times the probability of B. So that means we know the probability of A is 0.2. We know the probability of B is 0.4. So that means that the probability of the intersection has to be 0.08. Do you agree with that? And the same thing for the next one. Again, just using this formula, the probability of A intersect B intersect C, by definition, because we know it's independent, is the probability of A times the probability of B times the probability of C. So that's 0.2 times 0.4 times 0.5, which I believe is 0.04. Right? Do you agree with that? I'm going to do my math here again. 0.2 times 0.4 times 0.5 is 0.04. 0.2 times 0.4 is 0.08. Okay. So again, that's going to be helpful as we get to these story problems. And then I think that this might be my last one here. Says, predicting travel weather. Ron is planning to visit Paris on Thursday and Friday. A quick check of the weather report for Paris revealed that there's a probability of 0.2 that it'll rain on Thursday and a probability of 0.4 that it'll rain on Friday. Assuming that the likelihood of rain on Thursday is independent of the likelihood of rain on Friday, what's the probability that Ron will see rain on at least one of these 2 days? And so here's what's really, I think, important about this is understanding what those words mean, right? The probability of having it at least on one of those days. At least means like the probability of A or the probability of B or both, right? So like I'm going to draw a Venn diagram. I feel like that's easier. If this is A and this is B, it could be anywhere in A or B. That would be the probability of A union B. So now you got to think for a minute. This is going to make you go back and think about how do we find the probability of A union B. I'm going to move this over here. The probability of A union B, remember you take the probability of A plus the probability of B, but if you take all of A and all of B, remember that you've counted the intersection twice, so you have to subtract out the probability of A intersect B so that you don't count it twice. So the probability of A happening is, A is just the first day, right? There's 2 days. Basically, A is Thursday. So the probability of it raining on Thursday is 0.2. The probability of it raining on Wednesday is 0.4. And then how would I find A intersect B? Oh, that's our formula. Because they're independent, then that equals the probability of A times the probability of B. Right? See how it's all kind of building up together here? So we get 0.2 plus 0.4 minus 0.08, which I believe is 0.52. That means there's a 52% chance that it's going to rain on at least one of those 2 days. Okay? So the next step is we're going to work on some of these problems on Monday.